Welcome back. In this session, let us explore printf and scanf functions. We all know the syntax of printf function. It consists of a format string and list of arguments. Corresponding to each argument, there is a conversion specification, of course, depending on its type in the format string. So the format string consists of one or more conversion specifications, of course corresponding to each argument in the argument list. The function printf converts, formats and prints its arguments values on the standard output using the conversion specifications given in the format. So this is the regular activity of printf function. But there is one more interesting fact about printf function. Printf function returns integer value. And you know what is that integer? The integer is the number of characters that were printed by this printf function. Of course, excluding the terminating null character. You all know that every string ends with a null character. That null character is not counted, but remaining all characters are counted and it will return how many characters it is printing. That integer is the number of characters printed by printf function. Let us consider this simple program. Here I want to print a number of characters printed by this particular printf function. So what I do, I define an integer variable I, and to that particular I assign the value returned by printf function. Obviously printf will return number of characters printed. Then I am going to print number of characters printed by the printf function is equal to %d. So this I am sending it as argument. So I am going to print the number of characters printed. Let us run this particular program, my dear friends. Okay, let us save it and run. And you can see hello world is printed. That is, this printf function will print hello world. Then the number of characters printed by it. See, HELLO 5. See, \t and \n are considered as single character. \t is one character, \n is one character. So total number of characters will be 12. 5 plus 5, 10. This \t 11, \n 12. So total 12 characters. And I value is 12 and that value is printed. The number of characters printed by printf function is 12. Dear friends, the conversion specification for printf is having the following format: percentile sign and conversion specifier. This is the form of conversion specifier which we are using so far. But the conversion specification can contain additional optional fields other than conversion specifier. And these are the list of optional fields which a conversion specification can contain. One is flag field. See, the flag field by default plus sign, but if you keep minus sign, it causes the left justification. It can have minimum width field. For example, you want to print 256 in 10 columns. This minimum field width you can set it as 10. So in 10 fields the 256 will be printed. If you don't set any flag field, it will be right justified. But if you keep minus sign, the 256 in 10 positions will be left justified. The precision field only used together with floating points, my dear friend. The size modifier like H or L can be used. This code is our regular conversion specifier, my dear friend. Of course, this is compulsory. This is compulsory. These are all optional. This is optional. This is also optional. This is also optional. Size also depends on your type, my dear friend. So you can't say it optional. It depends on the type. Optional or depends on the type. So this conversion specifier, generally this entire thing is called as conversion specifier. That is, size modifier together with the code is what is called as conversion specifier. M is the minimum field width. See here you can have that M field which is minimum field width. See whatever written within the brackets, square brackets are optional fields. This dot P is for floating point numbers precision. Then this minus sign causes the left justification, my dear friend. Let us try to understand with simple programs. Now look at this example. Here we define an integer variable and we are assigning 254 to A. Now we try to use conversion specification with optional field. So what is the format, sir? It will have percentile sign, optional flag field that is minus sign. It can have minimum field width and the precision. Of course, the precision is only for floating point numbers. Okay, otherwise we will not use it. Then the conversion specifier. See, for integer directly you can use D. If it is a short integer, you can use HD. So this part we already using, my dear friends. These are the additional fields. Okay, these are the additional fields, my dear friends. Flag, minimum field width and precision. For integer we don't need precision. Now look at this, my dear friends. Here I am trying to print the value of A. Now here there is no flag field, minus sign is not given, so by default it will be right justified. So in 5 positions I want to print this 254. That is 254 will be printed in 5 positions and by default it is right justified. So what will be printed for this? 1 space, second space, then 254 is printed. Now here the next one, same 254 in 5 positions you want to print, but here it is minus sign, therefore left justified. So what happens? This 254 is printed like this. After 254 you can find 2 gaps. After 254 you will find 2 gaps because in 5 positions you are printing 254. Now the next one, if you consider, here the minimum field width is given as 2, but the length of 254 is 3. So it is ignored. Just 254 is printed, my dear friend. 254 printed as it is. Let us run this particular code and check the output. You can see, as I told you, first you can find 2 gaps, then 254 is printed because we not use backslash n or anything. Directly next one started 254 and after that you find 2 gaps because you made it left justified by using minus sign. Then next one 254 is printed even though you asked only 2 fields, that is minimum field width. If it is smaller than the length of the number, that is ignored. See, if you want you can use a very big numbers also like 10, let us use 10 here, okay, and here you can use 15 and here you can use, okay, 1 is ignored. Let us run the code. You see, so there are 7 gaps. After that 254 is printed and next 254, because it is left aligned, you can find 12 gaps here. 12 spaces gap is there, then the next number is printed. You can explore with more numbers, my dear friends. For integers, you just need the flag and the minimum field width, my dear friends. If the field width is smaller than the length of the number, it is ignored. If it is more, accordingly, depending on the flag, either if no flag is there, it is right justified. If flag is there, it is left justified. That's it. Now let us format the floating variable values using conversion specification. See, the syntax is percentile followed by optional flag field. Minus sign means it causes left justification. Optional minimum field width. See, my dear friends, if this field width is smaller than already existing length of the number, it is ignored. If the field width is more than the length of the existing number, then it is considered. Remember that. But for floating point numbers, this precision is very important. This P tells you after decimal how many values you want to print. Then we have the conversion specifier. Because it is floating point, F is the conversion specifier, no modifiers for this. So this will print normally the entire floating point as it is, my dear friends, depending on what is the value which is stored in the A location. Now let us try to manipulate this using the modifiers or using the additional optional fields. See, I want to print it in 10 positions, and after decimal I want to print only two values. Now let me take it once again, copy and paste. This time I want to make it left justified. You can explore with more options, my dear friend. These fields you can explore. You can just keep different values for this and explore. That is what I am trying to do, my dear friend. See, this time I try to keep the minimum field width less than the length of this number and see what happens. Okay, same thing without justification, let us do it. Okay, so we can try with more options, my dear friends. You can explore with more options, my dear friends. Maybe you want to print 5 values, that is after decimal you want to print 5 values. Let us see what happens. Okay, let us write on printf. Okay, now what I want to do, minus, I want to print in 15 positions dot 5 values f. The same, okay, backslash n is good for health. The same variable, my dear friends. And let us run this code and verify the output. Let me save this and run. Now you can see the output, my dear friends. See, first this number is printed as it is because the constant, floating constants are by default double, and that double constant is stored in floating variable, so that value may not be exactly printed like 24.568000, my dear friends. It may be stored in a different manner. Okay, that after a 6 decimal what happens we can't predict. Okay, and now the next one, you see, in 10 positions you want to print. See, actually this is 6 numbers. I want to print in 10 positions, and one more condition I put here. After decimal I want only two values. So what it will do is it will round off. It will not truncate last decimal, sir. That is 568, because 8 is more than half, more than 5. So what happened, that 6 is converted to 7. That is called rounding off will happen. So for this number here, the rounding off will happen. So what happens here is 24.57 happens here. And that 24.57, which is actually length 5, that is we want to print 5 values in 10 positions. 5 values in 10 positions. By default it is right aligned. You see, it is right aligned. The same thing, this time I am aligning left. See, here it is left aligned. Actually after this you will find gaps, but next number we printed in the next line, we are not able to identify that, my dear friends. Now here this is ignored actually. Here this field width is less than the length of the number, then it is ignored. Here also it is ignored, my dear friends. Just that 24.57 is printed because you want after decimal only two values. That 24.57 is printed. Exactly 24.57 will be printed, my dear friends. Okay, if you want, you can do one thing. You remove this backslash n, then you can verify. You will understand that, my dear friends. You will understand that. These two fellows will be printed exactly next to each other. These two fellows will be printed exactly next to each. Let me clear the terminal and run this code, sir. Now you see here, after 24 point, because it is left justified, after this you can find the gaps. You will find 5 gaps, then the next number is printed. And here after this immediately, again the next number is printed. Again next number is printed, no gap. Because the minimum field width which you given is smaller than the length of the number, so it is ignored. Am I clear? Now the next one, after decimal you want 5 decimal values. So 1, 2, 3, 4, 5 are printed here. A 0.56800 is printed. After decimal you want 5 decimals. So what happened? 5 decimals are printed. You want, you can take more decimals also, my dear friends. You want, you can take more decimals. For example, after decimal, you want to print 15 values. Let us try that also. Let us try 15 decimals, 15 values. After decimal, you want to print 15 values. And remember, floating point is having maybe precision up to 6 or 7 digits, 7 digits only. After that, what number you get, you can't expect it, sir. Okay, you get some unexpected results. So let us run this code, my dear friends. Okay, you see this number. The total 15 numbers are printed, but you see these numbers which are nowhere related to what you input. So that is what happens. Unexpected results happens because floating point is having precision only 6 or 7 digits. Up to 6 or 7 digits, it will give you correct value. After that, you get some value which is unexpected. I remember that. Now let us explore scanf function. Input data can be entered into computer memory from standard input device using scanf function. See, the syntax of scanf function is similar to that of printf. The main difference is the argument list. Here we are going to have the addresses of the variables, not variables. It is list of addresses of the variables. Because in the memory location you want to store the value, you have to send memory location address. So whatever value is scanned, that will be stored in the memory location address, my dear friend. Ignoring or omitting this ampersand sign is very dangerous. See, compilers may give warning, or some compilers don't even care, even try that. Then it would be very dangerous. Suppose there is an uninitialized variable, so which contains some garbage value. That value may be location of important memory location, and you are scanning some value at that particular location which may crash your system. So please be careful. Omitting this ampersand when you are using scanf is very, very dangerous. Am I clear? So that is the most important thing. And while scanning, when you write scanf, you have to write the conversion specifications without any space or gap. For printf, you can do all that, but here you should not give any space or gap between the conversion specifications, my dear friend. We have to use directly the conversion specifications. Next conversion specification. Only for character, you can give a space, then write down the character. For remaining variables, don't use any space, my dear friend. If you use space, how to handle it? Or if you use some other symbols here, how to handle it? Let us try to understand with examples. Let us see this. Here, we define 3 integer variables and asking the user to enter 3 integer values. See, if you don't do it, user see a blank screen and he'll not know what to do. So it is always better to write such statements to instruct the user what to do. Now scanf, as I mentioned, this conversion specification need to be written without any gaps. See, sometimes spaces may be accepted, but don't do that, my dear friends. Write without any gaps and write the variables with ampersand sign. That is, we are using address of the variables. Ignoring address of the variable is dangerous. So we are scanning the values and then we are printing the values. Let us see the output. Let us run the code. So I just want to enter the values 24, 34, 44. So the values are printed properly. Suppose, let me clear the terminal. Suppose if I give some special symbols here, what you need to do is, while giving the input, you have to give this special symbol. That is, after a value you enter, you have to enter hash, then you have to enter b value, then you have to enter hash, then you have to enter c value. Then only the correct values of a, b, c will be printed. That is, whatever extra symbols you given with the scanf, while giving input also you have to give the same symbols. Otherwise, the results are unexpected. Please note that. So here for this, if you want to get the correct result, what you need to do is, while giving the input 24, you have to enter hash, then 34, then hash 44. So it will understand A is 24, B is 34 and C is 44. And when you enter, you will get the correct result. But if you don't enter this way, for example, if you enter in a different manner, for example, if you enter the values like 23, see, you already got the output. You not enter the other values. Some values are assigned to BC because of that hash sign, and you got some unexpected results. So whenever you use extra symbols, while inputting, you have to give those extra symbols. For example, if you give dollar here, okay, while inputting also we have to give the dollar symbol, my dear friend. Please note that point. For example, if you run this code, see this time, first input for A followed by hash, input for B followed by dollar, input for C, maybe whatever value, 67. Then you will get the correct result. So this extra symbols whatever given, they must be written as it is. See, generally this extra symbols are used like for entering dates and other things. Suppose you want to enter date. So in that case, what happens? There will be slash. Okay, there will be slash symbol. So you want to enter date 15/6 dat. For example, today's date is 26/6-2023. Then you want to enter, you can write that. Okay. For example, you want to enter these values. Let us run this code once again and verify this. So here also today's date 26/6/2023. So A will be 26, B is 6 and C is 2023. So for such special purposes only we use this additional symbols in scanf. Otherwise using extra symbols other than conversion specification in scanf is very, very dangerous. You may get unexpected results, my dear friends. Whatever symbol you return, that has to be entered while scanning the values. Note that point. The conversion specification for scanf can also have optional fields similar to that of conversion specification of printf. The optional fields for conversion specification of scanf are the flag field, which is actually called the suppression flag, which is denoted by star. We'll understand with example. Then the maximum field width. See, my dear friends, it represents maximum number of characters you can enter for a particular variable. And of course, there will not be any precision field, sir. This is blank. We will not have any precision field. Remember that. The rest of the thing is same as your conversion specifier together with the modifier, that is size modifier. Let us try to understand with examples. Now let us consider the following simple program. Here we define two integer variables, asking user to enter two integer values. Now if you observe the conversion specification for A percentile 2D, that is maximum input of A can be of length 2. That is, A can be of length 2 digits only. Similarly, the conversion specification of B says percentile 3D. So the maximum field width of B can be 3. That is, B can be of length maximum 3. See, when I say maximum means it should be less than or equal to 3 digits only. A can be less than or equal to 2 digits. So as long as you give input for A and B, which is less than or equal to its maximum length, no surprising result. But once you give the input whose length is more than the maximum field width, what happens? Let us see with the example. So let us run this code, my dear friends. Now for A, I give input 2, which is of length 1, no problem. And for B, I give the input 34, which is of length 2, no problem. You will get perfect output. Now again, let us run the same code. This time for A, I give the input 24, which is of length 2, no problem. For B, I give, okay, unnecessarily some space was pressed. It may cause some errors. Luckily not caused. Okay, no problem. Fine. So A length 2 or less than 2, no problem. B length 3 less than 3, no problem. Suppose for A, I give the input of length 3 space for B I give the input of length 4. So what I expect for A 24 and B 456. But that doesn't happen like that, my dear friends. You get for A 24 and B value will be 5. See, what actually happened here is first two digits are assigned to A, then in the buffer that 5 is there and that buffer value is assigned to B. And this value may be in the buffer, my dear friends. Maybe after entering, it is clearing the buffer. Please note that. Okay, so please remember you can give maximum length 2 for A and maximum length 3 for B, my dear friend. Okay, let us try the same thing for float. Now let us consider this program. Here we define two float variables and asking user to enter two float values. And if you observe, the maximum field width for variable A is 3. See, for float variable, even the decimal point is also considered as one length. So maximum length is 3 means including decimal point. And maximum field width of B is 4 means including decimal point, maximum length of B can be 4. That is, you can give input of length less than or equal to 4 for B and less than or equal to 3 for A, including decimal point. Okay, so let us run this. First, let us save the program and run the code. So you are asking to enter two float values. So let us enter 5 for A and 7.2 for B. So as long as the length is less than or equal to maximum length, no problems. Now let us run this code again. This time I enter 5.5 for A and for B 5.46. The A length, because including decimal, the length of A is 3, length of B is 4, including decimal point, absolutely no problem. Perfectly printed. Now what happens when you take the length more than 3 and more than 4 for A and B, my dear friends? The same story happens, sir. 5.48. The length is 3, but I given 5.48. Then here I want 6.789. But what happens? You see, for A it is 5.4. This is not considered. And for B, this 8 is assigned and B value is 8. So when you use the maximum field width with scanf, you have to be very careful, my dear friends. This type of unexpected results may happen because maximum field width it can take is only 3 digits, including decimal. Here decimal also considered as 1 digit, sir. Length, it is also counted in the length. So first 3 will be assigned to A and in the buffer 8 will be there, that is assigned to B. So this is what happens with maximum field width, my dear friends. Of course, there is one more special field called suppression character. We'll try to understand with next example. Now look at this example, sir. See, we know that the syntax of conversion specification in scanf is percentile, and we can have this field, okay, flag field. The flag field can be star, sir. If I use star means that particular character which we enter is skipped. Okay, of course we can have additional fields like maximum field width, okay, and Z. This is the syntax. But when you do this, whatever value you enter, that is skipped, my dear friend. Up to this length. Up to this length, it will be skipped. So that is the important point to be noted, and we call it as suppression character. See, for example, I am having 3 variables A, B, C. I just assign some value to C so that instead of printing some garbage, I can print 20 only. See, actually, I want to print ABC value after scanning. Okay, so here I am scanning for A, but for B here I use this suppression character. That is what I use, percentile D. You see here, percentile star D. That is the second input, whatever you give, that is skipped. It will not be taken or it will not be assigned to any variable, my dear friend. And the third scan or the third percentile is assigned to B. That is the second input is skipped The second input is skipped. This second input is skipped. The third input is assigned to B. And for C, no value will be assigned, sir. Because of that, I already given some value to C, so that same value will be printed for C. So let us run this code and verify. So you asked you here we are asking user to enter 3 integer values. I enter 23, 45, 56. So generally what is expected, A is equal to 23, B is equal to 45 and C is equal to 56. But because of this suppression character, this 45 is skipped. It is not assigned to anyone. 23 is assigned to A, then 45 is skipped, then 56 is assigned to B. Now for C, no new value will be assigned. The old value, which is 20, is C is already 20, that will be retained. The old value will be retained for C, and when you print ABC, you get A 23, B 56 and C will be 20. Let us run and verify. And as I mentioned, A is 23, B is 56 and C is 20. See, generally these suppression characters are used for example, date, month and year. Suppose I have these variables date, month and year. See, while entering date, month and year, generally we keep that backslash or hyphen, something like that you write. So suppose you are used to write that, we want to skip that. We don't want to assign that slash to any variable. In such cases, we can use this suppression characters. For example, while entering it, so you can say dd, yyyy. Now here what I do is, first percentile d for A, then this is backslash C character. That is whatever character, like backslash or hyphen you enter, that has to be skipped. Then percentile D is assigned to, of course, month. Then again percentile star C. So this is ignored. Then again percentile D, this is for yyyy variable. So that is the idea, my dear friends. So generally suppression characters are used for that particular purpose. Okay, change these values also, dd, yyyy. So let us run this code and verify, my dear friend. So asking user to enter 3 integer values. So 26 slash 6 slash 2023. Now you see this slash and this slash are skipped because of this suppression character. And 26 is assigned to A, 6 is assigned to B, and 2023 is assigned to. So suppression characters are used for that purpose, my dear friends. Now let us consider strings. Strings defined as array of characters. So you can define them similarly the way you define one-dimensional arrays, but these are one-dimensional character arrays. There are two ways of initializing these strings. One is we can initialize with a string, or we can initialize with single characters. But remember, whenever you initialize in the second manner, we have to end it with \0, that is null character separately. See, for printing as well as scanning strings, we can use the conversion specification percentile s, my dear. So you can see this simple example. Here we initialize two strings, and using percentile s, we are printing both the strings. Dear friends, hello. Now we are having a special function which reads string from standard input, and that particular function is called gets function. So this is the syntax of gets function. So here I define a character array of length 20, okay, or a string of length 20 you can call it, and using gets I am going to scan the string and assign to some x, my dear friend. But there is a big problem with gets function. Okay, it is not safe. Why it is not safe, sir? Because it does not check for buffer overflow. See, the length is 20. Even if you input 30 characters, 40 characters, it will consider. Okay, so there is no bound check. Okay, so buffer overflows it will not check, and it may cause serious errors, my dear friend. Okay, of course there is a safer variant for this gets function, which is called fgets, which actually gives maximum size which you can enter. Okay, so that people generally use instead of gets, because gets being very. So fgets function reads a string from the stream up to the maximum length. Okay, or until the new character or end of the file is encountered. That is about fgets, my dear. The puts function takes pointer to the string as its argument, okay, and print string to the standard output followed by new line character. That is, after printing the character, it will go to the next line by default automatically. Okay, see, for example, you define this. Okay, this should be in the same line, sir. Sorry for printing error. Char string. So we initialized. So what it will do is it will print max. Okay, sorry for this. Max 8. And what happens? The cursor will be here. Suppose after this, suppose you are printing something that will be printed in the next line. So as I mentioned, you can try this program, my dear friends, because gets is a dangerous function. I am not trying in my compiler. You can try on some online compilers, my dear. Here I define a string of length 20 and you are asking please enter your name. So using gets function, you are entering the name, and using puts function, you are printing that particular string, my dear friend. As I mentioned, instead of gets, you can use fgets function. We can write str and you can say size of str. See, if I use gets, even if I give the input of length 30, that is also considered. So string can get a input of length 30 also. That is the problem with gets, my dear. Okay, please note that. See, the best way to input and output string using percentile conversion specification, my dear friend. That is, together with scanf, you can use percentile s specification, and together with printf, you can use percentile s specification for outputting the string, my dear friend. This is the simple example, my dear friend. Actually, we can also format the string input. So here we can have optional fields. One is star, that is suppression field. The other one is W, which specifies the total number of characters that will be stored in the string. Okay. So if you consider the following simple example, here what you are doing, scanf percentile s str. Suppose you give input computer, the entire computer is stored in this particular string str. But if I use this length field 3, only 3 characters will be stored in this particular string, my dear friend. So even if you enter the input computer, only first 3 characters are stored in this particular variable. So using this, what you call the field, this is the maximum field, maximum length, maximum number of characters that can be stored in the string, my dear friend. So using this field, we can restrict the maximum number of characters which can be stored in the string, my dear friend. Even we can format the string output using this optional fields. See this field, flag field with a minus sign causes the left justification, and this W is the specified field width within which you want to print the output, and this dot n specifies that only first n characters of the string will be displayed. It says that you are going to display only first n characters of the string. So let us try to take a simple program to understand this string input and output and conclude this session. Now let us consider the following example. Here we are defining a string of length 10 and asking user to enter the string. So using percentile s, you are scanning the string and that is assigned to str. Now we are printing the string using percentile s. Now here for scanning we not used ampersand. My dear friends, the name of the array is the address of the first location, constant pointer to the first location. So by default it is anyhow address, no need of writing ampersand. Remember that. If we write also, there is nothing wrong. So let us save and run this program. So enter the string, let us enter, and you will get the output computer. Now let us do the modification. With scanf, let us use maximum field width. See, remember, with scanf, this is always maximum field width. That is, whatever number of characters you input, only first 3 characters are assigned to str. So let us save this and run the program. So this time again I try to input computer, but only first 3 characters are assigned to str. So when you print, only first 3 characters are printed. So that is the idea, my dear friend. Now let us try to explore the printf with the additional fields. So for that, let me take the entire string. So let me save. So here with printf, we are having 3 fields. One is suppression. Okay, we don't have suppression field. Flag field we are having. Flag field will tell you the justification. Minus means left justified. Otherwise, by default, it is right justified. Then we have the field width. Okay, W is the field width, and then we have that dot S that will tell you how many characters you want to print. Okay, within that particular field width. Okay, my dear friends, here this W is always with printf, it is always minimum field width. W is minimum field width. Suppose the length of the string is more than that, it is ignored. Remember, okay. So for example, let us input some value, and for example, we do one thing, sir. Instead of scanning, because you want to experiment with printf, na, let us fix this. Otherwise, what happens? It will trouble us, because what value you entered, that may trouble, because we want to experiment with printf. Let us do this, some a b c d f, some string I enter. Okay, so that is my string. See, normally if you print, you will get a b c d e f. Now you want to print it in a field width of 10. That is, in 10 position, that a b c d e f will be printed. Let us see this, my dear friend. Let us save and run. Okay, for this, what I do, I clear this terminal so that you can clearly see output. Now you can see it is printed, but you see starting positions are vacant because it is right aligned. By default, it is right aligned. If you keep minus sign, it would be left aligned. So let us save and run. You get the same output. This time it would be left aligned. Now for this, if you keep the number of characters to be printed, see, this will not change the string, sir. Only that many characters of the string will be printed. See, even though we are having 6 characters, I want to print only 3 characters. So the 3 characters are printed in 10 locations which are left justified. So let us save and run the program. Now you see only 3 characters are printed. So this is how we can format the string output also, my dear friends. So this is about the basic input output functions, my dear friends. Thank you.